Welcome back. My name is Eitan Suez, Technical Marketing Manager at Solo.io. In this lesson, we demonstrate configuring HTTPS using the Kubernetes Gateway API. If you recall from the previous lesson, we walked through a sort of canonical example of provisioning a gateway, programming it, and configuring a route to a backing workload, which was a sample application known as HTTP bin. In this lesson, we build on that example, and we start from where we left off, but we reconfigure things for HTTPS. And so that will involve a number of steps, creating a certificate and configuring the gateway with an HTTPS listener and giving it that certificate so that it can serve it to clients, and then retrofitting our route, and also redirecting HTTP requests over to HTTPS. So let's get started. Go ahead and start up our sandbox environment, and we are ready to sort of begin the exercise. Let us begin by ascertaining that requests are actually functioning over HTTP as a starting point. So you see here a curl request to http-bin.example.com to the headers endpoint seems to resolve properly, and we get a response. So that all seems to work, and we want to retrofit that for HTTPS. And so the first step is to generate a certificate. Now there are many options here for creating a certificate, and for the purposes of learning, what we're going to do here is use a command line tool known as the step CLI, which is very similar to OpenSSL or other such tools. Here we are actually asking the step CLI to create a certificate, a self-signed cert for the host name http-bin.example.com with the certificate key files names referenced here for it to use. So we run this command, and now we have these files, and we need to then take these files and compose them into a Kubernetes secret of type TLS, and so that's done with the kubectl command, like so. So now we have a secret, and we should look at the retrofitted gateway configuration. So what stands out here is the fact that in addition to the HTTP listener, we now have an HTTPS listener on line 12 through 19, port 443, of course, the host name, and the TLS configuration. The mode is terminate, as opposed to pass-through. A pass-through configuration would actually not terminate TLS and allow the backing workload to deal with the serving of the certificates to clients and so on. But in this case, it's the gateway that's going to do it. That's the more typical scenario. And the reference to the certificate is given there on line 19, HTTP bin cert. And so let's go ahead and apply this gateway. And then turn our attention to the route. So if we look at this route configuration, what's interesting about it is line 9 there, section name HTTPS. We haven't seen that before. And if we look more closely at the gateway, we see that each listener has a name, HTTP and HTTPS, and we're choosing to attach our route only to the 443, the HTTPS listener. And so that's an interesting thing to observe. We can go ahead and apply our route, and then simply verify that if we make a request over HTTPS, here let me put that at the top of the screen so we can see exactly what we're talking about. I have to include the insecure flag because I'm using a self-signed certificate. In real scenarios, of course, we would have a bona fide certificate, and that would not be necessary. We'd be having certificate issued by a valid certificate authority. And the request succeeds. Now this curl request was a verbose request simply so that we could actually see the TLS handshake taking place here. So this is indeed a TLS request. All right, so there is one more thing we want to do, which is redirect requests from HTTP to HTTPS. If we were to right now make a request over HTTP, we would get back a 404, and that's because our route is not attached to that listener, right? And so we have to typically it's a polite thing to correct, so to speak, errant clients. I've often done it in my browser. I type HTTP as a matter of course, but I really meant HTTPS. So let's look at another route. This is different from what we've seen before. Here, let me put that at the top of the screen. It's called HTTP bin redirect to HTTPS. The host name is the same host name as the other route, but in this case, the rules there's two things. The parent ref is the section references section name HTTP, which means it binds to the port 80 listener. And the rule is something we haven't seen before, this reference to a filter of type request redirect. So there are different types of filters. We'll look at other ones in subsequent lessons. But this one knows how to redirect requests. So it basically says if the request, any request coming in over HTTP should be redirected to HTTPS, the scheme is changed, but the rest of the URL is preserved, which is kind of nice. And we could see that in action by essentially testing a request. If we apply this redirect rule and submit a request to this headers endpoint, notice that the location header says HTTPS, http://header. So the URL is preserved, the response is 301, moved permanently, and then if we follow redirects, we should actually see the sort of redirected request is actually returning over HTTPS. All right, so that summarizes the exercise. Let's go ahead and extract what are the main lessons learned. Here we saw an example of terminating HTTPS requests at the gateway, and the fact that we can bind routes to specific listeners using the section name field. And we saw an example of a filter routing rule, a request redirect filter to be exact. And the interesting observation that we defined two routes separately as separate resources, and they both sort of were merged into the configuration for our gateway at the end of the day, right? We have a gateway that's programmed with two routing rules, one that binds to the HTTP listener that redirects, and one that binds to the HTTPS listener, which then serves our request in a secure fashion. All right, so that concludes the lesson. Where do we go from here? The next lesson is a rather interesting one, in that up until now we haven't really given much thought to the fact that there may be multiple teams working, the fact that there may be an admin team with cluster operators, and they each play a role. And oftentimes the way we typically do things is using a shared gateway. Oftentimes a single gateway will serve requests, have multiple routing rules to different backend applications. And so we'll look at that example in the next lesson. Thank you for your time, and we'll see you then.